Good morning, class. Here's Chapter 7, Systems of Equations and Inequalities, Section 7.8, Determinant and Cramer's Rule. All right, so we covered systems of linear equations in 2 and 3 variables, nonlinear equations, matrices, Gaussian elimination, and now solving systems of equations with Cramer's Rule determinants. The objectives are to evaluate the determinant of a 2 by 2 matrix. Use Cramer's rule to solve a system of 2 equations containing 2 variables. Evaluate determinant of a 3 by 3 matrix and use Cramer's rule to solve a system of 3 equations containing 3 variables. So recall, matrices are classified by their dimensions, the number of rows and columns. A matrix with m rows and n columns has dimension m by n. A square matrix has the same number of rows as columns. The dimension of a square matrix is n by n. A matrix with only 0 elements is called a zero matrix. The element of matrix minus A are the additive inverse of the elements of matrix A. Here's an example of a matrix with 1 and 2 rows, 1, 2, and 3 columns. So we call it a 2 by 3 matrix. The operation of matrices basically are very similar to operation of numbers. A plus 0 is 0 plus A equals A. This 0 is a zero matrix. A plus minus A is A minus A equal to 0. This is the opposite matrix. A plus B is the same as B plus A. A plus B plus C is A plus B plus C. This is a commutative property. This is the associative property. It works with additions, not with multiplications necessary. Summary of matrix addition and subtraction. If A and B are both m by n matrices, then the sum of A and B, A plus B, is a matrix obtained by adding corresponding entries of A and B. The difference of A and B, A minus B, is obtained by subtracting corresponding entries of A and B. The product of a scalar K, meaning a real number, and a matrix A is the matrix Ka, each of whose elements is K times the corresponding elements of A. The product of AB of an M by N matrix A and N by K matrix B is an M by K matrix and is found as follows. To find the ith row, jth column element of AB, multiply each element in the ith row of A by the corresponding element in the jth column of B. The sum of these products give the elements of row I, column J of AB. The product AB can be found only if the number of columns of A is the same as the number of rows of B. The final product will have as many rows as A and as many columns as B. Here's the calculator, some sort of a technology, including TI calculator. To enter matrix, you go to matrix editor. To get to matrix editor, found by pressing second and x to the power of -1, use the arrow key to the right to edit the dimensions you want and press enter. Put all the entries and press enter. Identity property. An n by n square matrix whose diagonal entries are ones while our other entries are zeros is called the identity matrix of I sub n. That means dimension is n by n. For example, I sub 2 would be 1, 0, 0, 1. Notice the main diagonal is 1. Every other entry must be 0. If A is an m by n matrix, then I sub m times A equals A times I sub n equals A. And if A is an n by n matrix, then n times I sub n equals I sub n times n equals A. The identity matrix works like an identity element for multiplication of numbers. So that's important to remember. Solving systems with Gaussian elimination, matrices, and technology. Matrix methods enable calculators and computers to efficiently handle and solve large systems of equations. Matrix row transformations. Efficient implementation of echelon methods. Given a system of equations, a sub 1x plus b sub 1y plus c sub 1z equals d1, second and third equations, we can write the rows a sub 1, b sub 1, c sub 1, d sub 1, and the second row, the third row, those are the rows that are the equations. These are the columns. They correspond to x, y, z, and this is the constant. This is called an augmented matrix, where each member of the array is called an element or entry. The rows of an augmented matrix can be treated just like the equation of a linear equation. So in essence, this is equivalent to this one. So this part, if you write this matrix, is called the coefficient matrix. This one, the last column, represents the constants. So we can do the matrix transformation because in essence, these two are equivalent. So what would be matrix transformation? Row transformations resulting in a matrix of an equivalent system for an augmented matrix are whatever we do to equations, we can do to rows. Any two rows may be interchanged. That means you are interchanging equations. The elements of any row may be multiplied by a non-zero real number, meaning one equation, both sides multiplied by anything you want as long as it's not zero. And that's the key. It can't be zero. Any row may be changed by adding to its elements a multiple of the corresponding elements of another row. The concept of elimination, if you recall, you can multiply an equation by some number and add it to another equation. Matrix methods to solve systems of linear equations. REF, short for row echelon method. Apply row transformations to get ones along the diagonal and zeros below the augmented matrix. Or REF, reduced row echelon method. Apply row transformation to get ones along the diagonals and zeros both below and above the augmented matrix. All right, now the new stuff. Determinants. A matrix is square provided that the number of rows equals the number of columns. For any square matrix, we can compute its determinant. Suppose that A, B, C, and D are four real numbers. The determinant of a 2 by 2 matrix A, B, C, D, denoted by, it looks like an absolute value sign, A, B, C, D, is the cross product as follows. AD minus BC. So take a look. AD, BC, their difference is the answer. One easy way to think of it as a cross product or a 2 by 2. All right, so we want to evaluate the determinant here. You just go with the cross product here, which makes it 2 times 9 minus 5 times negative 4. This is 18. This is positive 20. They add up to 38. We go with the cross section of these two, meaning negative 3 times negative 5 minus 8 times 0. This is 0. This is 15. The result is 15. So if we were to use a TI calculator, how to enter matrix editor, matrix editor found by pressing second x to the power negative 1. Use the arrow keys. I've done that before, so I'm repeating the same thing. To the right to edit the dimension you want and press enter. Put all entries using the arrow keys, press enter. So here's a matrix 2 by 2 that you've entered, and this is one of the two. In fact, this is part A. Now, the first one is names, the second one is math, the third one is edit. Under math, you have a bunch of one. The very first one is determinant. You write determinant, and then you have to go with the name and put matrix A. If you don't put matrix A, if you put just A in parentheses or brackets, doesn't do the job. Determinant of matrix A, and it gives you the same answer as here. Let's look at quickly one more example. We want the determinant of this matrix. When we put it in this format, we are asking for the determinant. If we are given this, we're going to say determinant of A, or determinant of this, which is now writing it in essence absolute value sign. The product of these two minus 3 times 8. And the product of these two, 6 times 4 minus that, and that's negative 48. Minus 24, minus 24. Cramer's rule. Gabriel Cramer. Cramer was a Swiss mathematician that came up with this. Cramer's rule for two equations containing two variables. The solution to the system of equation looks like that: ax plus by equals s. This is equation number 1. Cx plus dy equals t. This is equation number 2, is given by x is the determinant of st over bd, and the determinant a c b d. This is d sub x over d, and this is d sub y over d. I want to explain what they are. First and foremost, what is d? D is called the determinant of the coefficient matrix, which is writing this matrix A, B, C, D, getting this determinant, which is the product of AD minus BC. This must be non-zero, otherwise Cramer's rule fails. And then, so this is D. So what is D sub X? I want you to compare and see. Basically, you keep the D. For D sub X, we replace the first column of D by the solution matrix for D sub X, which is S and T. Notice S and T. And we replace the second column of D, here's D, the second column, by the solution matrix for D sub 1. So for D sub X, the first column of D is changed to that, the solution or the constant. They call it the solution or the constant. For D sub Y, you look at D, and because Y is the second variable, you change the second column to S and T. Take a look. So here's an example. We want to use Cramer's rule to solve the following system: 2x plus 4y equals negative 2 minus 5x minus 2y equals 13. And basically, when we have a system of equations in two variables, we write the coefficient matrix A, B, C, D, and we want to find the determinant of that. So we want 2, 4, minus 5, minus 2. We want this determinant. That's called the D. So we go with the cross product, 2 times minus 2 minus 4 times negative 5, or negative 5 times 4. This gives us negative 4. This gives us positive 20. They add up to 60. Now, how do we find d sub x? I want to make sure we understand. You look at this one, and the next one is d sub x. The first column represents the x, if you will. And the second column represents the y value. So the first column, since we want x, the first column, we're going to replace it with the constant on the or the solution called minus 213. And now we evaluate this again. The cross product, that means minus 2 times minus 2, minus the product of 13 and 4. This is a positive 4. This is negative 52, gives us negative 48. So with the d sub x, there is one more, and that's d sub y. We go back to the d. The first column is unchanged because we want d sub y. The second column is changed to this. So replace this 2 with this 2 for d sub y. So that's how we make the change. Now, of course, we repeat the determinant 2 times 13 minus negative times negative 2. So this is 26. This would be positive 10, with this makes it negative 10, so the answer is 16. Now, x is dx divided by d. So first, understanding the d and d sub x and d sub y. Now we divide this one by this one to get x, this one by this one to get y. So d sub x minus 48 divided by d, which is 16, results in negative 3. For y, we divide d sub y by that, and that gives us 1. So the pair is negative 3, 1. So the pair is negative 3, 1. You should check. So for example, 2 times negative 3 is negative 6. 4 times 1 is 4. Negative 6 and 4, they add up to negative 2. Negative 5 times negative 3 is positive 15. Minus 2 times 1 is minus 2. Positive 15 minus 2 is 13. So check your work afterwards. For this system, we want to use the Cramer's rule. 5x plus 7y equals negative 1. 6x plus 8y equals 1. So D represents the determinant of the coefficient matrix. So D is the determinant of 5, 7, 6, 8. See, when you use matrices, sign, and then symbols, then you have to put determinant. So 5 times 8 minus 6 times 7. So These two minus these two. 40 minus 42 is negative 2. Now, what is d sub x? The first column, 5 and 6, changes to the constant or the solution matrix. Now, these 2 minus 1 times 8 minus the product of these two, 1 times 7. So this is negative 8, this is negative 7, the result is negative 15. What about d sub y? D sub y is the second column that is changed. So this one you keep, this one you change to the constant column. The product, cross product, 5 times 1 minus 6 times negative 1. And we have 5 plus 6 is 11. So x is d sub x divided by d, which makes it negative 15 over negative 2, or 15 halves. Y is dy over d, which makes it 11 over negative 2, or minus 11 halves. So the solution is 15 halves comma negative 11 halves, or if you say the solution set, then you use braces and you put those. So you check. I'm going to check one of them quickly. If I multiply 5 by 15, I get 75 halves. If I multiply 7 by negative 11, I get minus 77 halves. So 75 minus 77 is minus 2 halves, gives us negative 1. You can check the second. So you really have to check to be on the safe side. You could edit and write matrix A, B, this is matrix A, this is matrix B. They don't have the capital D there, okay? And here's matrix C, so you call them A, B, C now. That's fine for the sake of technology. Now, the ratio of determinant of B to A is your X, and the ratio of the determinant of C to determinant of A is your X. So take a look at what we have. Determinant of a B, you have a determinant of A, and then you have it, and then you change it to a fraction, that's 15 halves X. Determinant of C to determinant of the A is negative 11 halves. So this is using technology. And you can do that pretty fast. What happens when we have a 3 by 3 matrix? Determinant of a 3 by 3 matrix, the value of a determinant of a 3 by 3 matrix may be defined in terms of 2 by 2 determinants as follows. So you decide to expand it with respect to one of the columns or rows, and it makes no difference. For example, if you decide to expand it with respect to this, then the way it works, you're going to multiply, this one will go away, and then if you're using the first entry, this one goes away, this is left. So for the sake of argument, so you can see if I want to use the first entry, I say a sub 1, 1 times the determinant of what is left. So I want you to see just this one. Just look at this one. Now for the next one, a sub 1, 2, and the determinant of what is left. Take a look. This is what is left. And the last one, a sub 1, 3 times what is left. What happens to the sign? The very first entry takes a positive sign, then they alternate. I'll discuss this further in a moment, but just remember that the very first one takes a positive sign and then alternate. Even if you go down and you want to expand it with respect to this column. If you want to start with this row and expand it, this one start with the negative sign and then they alternate. Okay. Now, what are we dealing with here? This is a 2 by 2 determinant left after removing row and column containing A11. So you move this row, you move this column. So just this one again, you're left with this. That's what they're referring to. What is this? A 2 by 2 determinant left after removing row and column containing A12. So that's the same row, but the column now, this time, this one is moved. What about this one? 2 by 2 determinant left after removing row and column containing A13. Now, of course, the row was the same row, but the column is this time, this one, and this is what is left. The 2 by 2 determinants are called minors of 3 by 3 determinants. So this is a minor, this is a minor, this is a minor, which with respect to A11, A12. Sometimes they put A11, sometimes they put A1 comma 1. I'll show you both makes no difference. And let me erase the mess. Here's the second method. You put the same determinant side by side. So you put two of them and you go down in this manner and you multiply them and add them up. Multiply this 3 plus multiply this 3 plus multiply this 3. Then you go this way, you add them up. You multiply this 3, you multiply this 3, you multiply this 3, you add them up. The sum of the blues minus the sum of the reds or purples, if you want to call it. So determinant of A is, look at the blues, A11, A22, A33, and the next and the next. We add them up. Look at the purples, we add them up. But the blues take a positive sign, this one takes a negative sign. This is the second method. And note, we can choose to expand across any row or column. Now, more on this sign as far as the terminology is concerned. Let M sub ij be the minor or element A sub ij in an n by n matrix. The cofactor of A sub ij written by capital A sub ij is capital A I sub ij -1 to the power of I plus j times capital M sub ij. I want to tell you what that means. So first, you remember the determinant of this one, how we got that, okay? And we can write A sub 1 comma 1 or just A11. I want to explain this concept. This concept refers to the determinant including the sign. Remember, if I want to expand it with respect with the very first row or even very first column, the very first entry takes a positive sign. I cross them and I have this one, and then they alternate. Take a look at what happens here. We want to expand it with respect to column 2. Remember what I said? I said we start with positive, everything else alternate. So you really start with negative. This is -1. But how do you arrive at it? This is -1 to the power of I plus j. If you look at the first one, a1, 1, 1 plus 1 is 2, -1 to the power of 2 is 1. So this is either positive or negative. So when you are here, the sum of these two numbers is even, and -1 to the power of even is +1 plus -1. When you raise it to the power of even, is +1. When you raise it to the power of odd, is -1. So if you're going to go with this one, this has the entry 1, 2. 1 plus 2 makes it 3. -1 to the power of 3 makes it negative. And then 2 plus 2 is positive. 4 even makes this positive. So they alternate. So take a look. This becomes negative, positive, negative. As long as you have one of them, the very first one, you don't have to go with those. So they alternate. Okay. Now, notice if we want to go with this one, 3 plus 1 is 4, -1 to the power of 4, and then you get rid of this. This is the determinant. A sub 3, 2, you need this number. They will alternate. -1 to the power of 3 plus 2 is -1 to the power of 5, which makes it negative, and so on. So I want to make sure you understand this is negative sign. This is positive, negative. This starts with positive. By positive, I mean +1. Negative, positive. They will alternate. You don't have to worry about this too much. Okay, but you understand, just remember this starts, if you go with this one, it starts with a +1, then they alternate. Okay, always go with the first or row or column, unless you have a row of zeros. That makes life easier. Actually, the determinant ends up being zeros. It ends up being a 0. So you can expand it with respect to anything. But as far as this one is concerned, note the sign alternates. By that, I mean these numbers that you see, the sign, the one that gives you A sub ij. In other words, this is the minor, including the sign becomes cofactor. As far as the terminologies are concerned, you don't have to worry about it too much. Evaluate the 3 by 3 determinant. And again, I'm writing this is the cofactor. If you just remember, if you want to expand it with respect to the first one, this takes a positive sign. You don't have to worry about it. And then they alternate. I can't emphasize this enough. But if you were to write this, we would write for this one, the sign would be -1 to the power of 1 plus 1, because this is A11. This is A12. This is A13. So I want to show you that. So this one, -1 to the power of 1 plus 1, and then times this. So let's actually do this. Different color. So if you drop this, you have 1. It happened to be 1, any number, 1. And then -1 to the power of 1 plus 1 times this. Determinant. Okay. And again, notice this takes a positive sign, right? So you don't have to write this, just alter. The next one must become negative. So we write plus -1 to the power of I plus j. For this one is 1 plus 2. And then we have the 2. Let me just, so this is a 1, 2, and we're going to cross this. So -1 to the power of 1 plus 2 times 2 and times this determinant 3127. 3127, -1 to the power of 1 plus 2 times 2. Please understand again, this is positive, this is negative. Finally, the third one. For the third one, this is a 1, 3, which is number 1, and this is the determinant. So -1 to the power of 1 plus 3 times this number, which happened to be 1, times this determinant. So -1 to the power of 1 plus 3 times this number happened to be 1 times this determinant. And again, notice this is positive. They alternate. Just remember they all, so you don't have to worry about that. But -1 to the power of I plus j. The reason it's important to have that, if you have a huge matrix, a very large matrix, and you want to expand it with respect to a specific row or column because that has too many zeros, makes life easier, and you don't have to alternate, you have to figure out the first one actually. So this is 5 times 7, 35, minus 6, 29, and we multiply it by 1. This is 3 times 7, 21, 2 times 1, 2, and that makes it 19. This is minus 2 times 19, which makes it minus 38. This is 3 times 6, 18, minus 2 times 5, 10, which makes it 8. This whole thing is just 1. So we have 1 times 8. So we have 29 minus 38 plus 8, and we get -1. Evaluate the following determinant, and we can go with the expansion of any row or column. We can choose to expand across row 1. Row 2 or column 2 would have been better. I highly recommend you try it at home. Why? Because one entry is 0, that makes it, because 0 times anything is 0. So if you go with this row, you have to Start with the negative, by the way, because they alternate, right? So this positive, this negative. So -3, and then you get rid of these two, and you have this one, and this one. But then the second one, 0, makes it easier. So in essence, you have only 3 and 4 to work with. If you go with this column, you have only negative and -2, because this entry makes the product 0. In any event, so let's start with this. So I'm gonna, if I cross this out, what do I have? 5, and it starts with positive, times the determinant of this. 5 times the determinant of 0, 4, -2, 1. Minus, because they're gonna alternate. Minus, now minus this number times the determinant of what is left, 3, 4, -5, 1. Plus 6 times the determinant of what is left. And again, that sign that was -1 to the power of I plus j, you don't have to worry about that. Just remember the alternative. This is positive. This, see, start with positive, then we have a negative, and we have a positive if there were more negative. So just, so negative, positive, negative, but they alternate. And now let's do this. This is 0 minus -8. This is minus -8 or plus 8, 3 times minus 20 plus 6 times 3 times -2, which is -6 times -0. So we write it in this fashion. So this is 8. This is 23. This makes it 40 plus 8 times 23. 8 times 23 is 184 minus 36. And when you add them up, basically this one and this one gives you 4, with 184 is 188. I mean, this is basic math. We could do this with technology. We're going to put matrix A, B, whatever. You have to put the proper size, which is 3 by 3. You have to input all those numbers in their proper place, and then just go with the math, and determinant of B is 188. Or we can do the second method. I want to quickly show you. Remember what I said? I remind you that we go with these 2 arrows, 3 arrows down. Start from the very first entry, go diagonally down. Okay, which makes it 5 times 0 times 1 plus -8 times 4 times -5 plus 6 times 3 times -2. That's the diagonally blue one. Minus, now we go diagonally, we add them up and subtract from this. So this would be -5 times 0 times 6 plus negative 2 times 4 times 5, plus 1 times 3 times negative 8. And we add all of them and subtract from the blue ones, minus those. And it becomes 124 minus negative 64, which makes it 188. So in some instances, people find this method easier. If you're doing it by hand, as long as you can do one of them by hand, then the rest of them you can do by technology. And that's the idea. The technology is to speed up the process, but we have to know how to handle it. Now, when it comes to Cramer's rule, we do a similar methodology for a 3 by 3 as we've done it for 2 by 2. Cramer's rule for 3 equations containing 3 variables for the system of 3 equations. So D is the determinant of a coefficient matrix. D sub x, these 3 are replaced with these 3. D sub y, these 3 are replaced by these 3. D sub z, these 3 are replaced by those. Okay, so take a look. And x was d sub x divided by d, doesn't change. Y was d sub y by divided by d, that doesn't change. This was for the 2 by 2. Now we add the z for d sub z divided by d for the 3 by 3. You can try this by hand. Ultimately, you do use technology, but let's just quickly write this. So D would be the determinant of a coefficient matrix. So column-wise, it's easier for me to write 2, 3, 1. The y, I don't have any here. So, oh, y, I have it, I'm sorry. 3, 7, negative 1. I don't have a z. So 0, negative 4, 2. That looked strange. All right. Now we have to evaluate this expansion with respect to one of them. So 2 times the matrix, this one, 3 times the matrix 3, 1 minus 4, 2, and 0 times this one. Will result in this answer. Please understand that we are using this column just so we make some changes, everybody. That's why we are using that. So you are exposed to various methods. So when you go with that, the first one doesn't change. Okay. In other words, This is the first one, okay. And then they will alternate. Notice this 3 makes a negative sign, this one takes a positive sign. So positive, negative, positive. I want you to see that. So what happens, for example, for 3, let me erase and show you. For this one, we get rid of this. So we have 3, 0, minus 1, 2. Notice. Now, for this one, we get this one. Now, I'm not going to take time to go over that. Basically, this determinant is the cross product, 7 times 2 minus negative 1 times negative 1, negative 4. This one is 3 times 2 minus negative 1 times 0, which makes it 0. 3 times negative 4, this is 0. And then you have the answer. Okay. Now, for d sub x, we are going to replace this one with this one. So the very first column of D is changed to a constant or solution matrix. So this becomes 4, negative 3, 9, and we're going to do that. So let me erase. And we're going to expand with respect to this. So 4, again, the first entry, this one is positive. So cross this out, this is what is left. So take a look at this one. Just look at the first one. 4 times, cross this out. Well, let me actually do this. Cross this out, right? We have this one. Now, if we erase this and now cross this out, you end up with this. If we erase this and cross this out, you end up with this. See, 9 times this. And now this is again easy. You are going to evaluate it. I'm not going to waste time on that too much. Let me just do the erasing. So 7 times 2 minus negative 1 times negative 4. We have a 4 in front. Minus 3 plus 3. 3 times 2, this gives you 0. Plus 9 times 3 times negative 4, this gives you 0. And so you work it out. You end up with too many steps here. Just you can write. You should be able to get to the answer from here to here pretty fast, everybody. Since I have them, I'm going to show you, but you really don't have to take that many steps. Now, the next one, we go back to the D, we change this one for Y, D sub Y. We change this one to 4, negative 3, 9. Notice. So this one has been changed. And again, if we expand it with respect to the first one, so this is the one that has been changed, everybody. Okay. But we're going to expand it with respect to the, let's say, first column. Okay. The first row would have been a better choice. Let me erase everything. And again, if you want to go with this and this, you get 2 times what is left. 2 times this. Okay. And then let me erase. Okay. So this was the column, and now here's the second entry. First of all, takes a negative sign. And then look at the what is left, 4092, 4092. And finally, 1 times what is left. And you evaluate it. So I'm not going to dwell on evaluation too much because the product of these two minus these two, these two minus these two, these two minus these two, and that should be a fairly easy cross product. Okay. And you end up with Tony. Okay. Again, seems to me there are too many steps. I just wanted to make sure we are comfortable with this concept of determinant because it may be brand new to some students. Finally, we need to find d sub z. So d sub z, you go to the d and you get rid of the third column. So this was it. We got the d, we got the d sub x, we got d sub y, and now we're going to write d sub z by changing the third column. So that's pretty straightforward, everybody. And now you want to expand that accordingly. So again, we change the third column. Remember that. So if we want to expand it again with respect to this column, getting rid of this will result in this. So 2 times the determinant of that. We alternate the sign for the second one. That's why we get a negative here. Negative and the number 3 times what is left. 3, 4, negative 1, 9. Okay. And then plus this number times whatever is left. So I hope you see it's very straightforward. Again, I'm going to assume you have an easy time calculating this 2 by 2 determinant by just think about the cross product. 7 times 9 minus negative 1 times negative 3, 3 times 9 minus negative 1 times 4, 3 times negative 3 minus 7 times 4. And again, remember, the signs alternate here, positive, negative, positive. So you put them together and you end up with negative 10. So x is d sub x, which is minus 50 divided by d, making it positive 5. Y is d sub y divided by d. 20 divided by negative 10 makes it negative 2. And finally, z is d sub z, which is negative 10 divided by d, which makes it positive 1. And we have the answer as 5, negative 2, positive 1. It's really a good practice to check. So we're going to put this into the first equation and it checks. We're going to put that into the second equation and that checks. We're going to put that into the last equation and that checks. So the process may be a tad tedious, but pretty straightforward. And ultimately, you can do this by technology as long as you can show work and you're able to do one of them and you understand every step, then you can always use technology. We want to use Cramer's rule to solve this system of equations. So the very first thing is to write the D. The D is the determinant of the coefficient matrix. 1, 3, 2, 2, 5, 6, 1, 1, 7. Let's expand it with respect to the first row. So we're going to get rid of this. And we're going to have a 1 times the determinant of that. I'm going to explain the rest of them, but take a look at this one. Even if you don't write this, that's fine. It has to be positive. Then it alternates. But we are adding, remember, this is the first A11. That's why 1 plus 1. This is A12, 1 plus 2. This is A13. That's why 1 plus 3. And then we alternate. That's the nature of negative 1. And so for the next one, we cross this one and we end up with this one. 3, 1, 2, 7. For the last one, we cross this one and we end up with this. I hope you see that it's really not too bad, everybody, but it's a little bit, time consuming. And so you do the math, it's the cross product. So the first one is 35. Let me just use a. So this is 35. 5 times 7, 35. Minus 6 is 29. This one, 3 times 7, 21. Minus 2 is 19. This is 3 times 6, 18. Minus 10 is 8. So we have 1 times 29 is 29. Minus 2 times 19 is 38. Plus 8. And we get negative 1. For d sub x, this first column changes to this constant column. And again, when you want to expand it with respect to this one, for example, the first one becomes 1 times this, and you can figure out the rest. So this is it. And remember the sign, this is positive 1, negative, positive, they alternate. I'm just writing those. Here's the second one. If you cross this out, you get this one. If you cross this out, you get this one. Now, I'm going to leave it for you to do the math. You end up with 2. By now, you should know how to take care of the business here. Now, for d sub y, we are going to use this instead of the second column, and you're going to evaluate the determinant, again expanding with respect to the first row, so you end up with this, right? And again, please understand this is positive, negative, positive, they alternate. If I get rid of this, I get this one. If I get rid of this, I get this one. Please understand, they happen to be, all of them, they happen to be one here. So this is one, this is one, this is one. Okay. Whereas here it was 1, 2, 1. So we have the 1 and 2 and the 1. Okay. And you do the math, you end up with -2. We want to do d sub z. That means this last column is changed. So this will replace the last column to get d sub z. And if we expand it with respect to this one and cross this one, we get this one. Just look at this one. Again, please, you don't have to memorize anything. The first entry takes a positive sign, then they alternate. And look at the numbers, 1 here, 2 here, and 1 here. That's the first row. Now, if I erase this one and this one, and go with this one, I get this one. If I erase this one and I go with this one, I get this one. And I do the math, and I end up with 1. So again, doing the math, by doing the math class, I mean the cross product, 5 times 1 minus 3 times 6, 3 times 1 minus 3 times 2, so on and so forth. You can do this. I mean, just for the sake of argument. So this is 5 minus 18 is minus 13. This is 3 minus 6 is minus 3. This is 18 minus 10 is negative, is 8. 3 times 8 is positive 8. So we have negative 13 minus minus plus 3 plus 8, they add up to 1. Okay. So what is x? D sub x, which is 2 divided by 2, which is -1, making it -2. What is y? D sub y, which is -2 divided by d, -2 divided by -1 is +2. And finally, d sub z divided by d gives us the z1, divided by -1 gives us -1, which means here's the set of solutions, -2, +2, -1. You have to put it into the original equations. Just as an example, I do the first one, x plus 2y plus z equals 1. -2 plus 2 times 2, 4, -2 plus 4 makes it +2, with -1 makes it +1. So I did the first one, you can try the others. Again, I can't emphasize this enough. Be able to do one by hand, and then you can use technology, understand the concept, and you're fine. All right, inconsistent and dependent systems. Cramer's rule with inconsistent or dependent systems. If d is 0, the determinant of the coefficient matrix is 0. And at least one of the determinants, d sub x, d sub y, or d sub z, is different from 0, is non-zero. Then the system is inconsistent and the solution set is an empty set. This is phi. Which represents an empty set, or you use braces with nothing in it. If d is 0 and all of those determinants, d sub x, d sub y, and d sub z, all of them are equal to 0, then the system is consistent and dependent so that there are infinitely many solutions. So in short, if d is 0 and at least one of them is not, it's inconsistent. If all of them, d sub x, d sub y, and d sub 0, all of them are 0, that means then it's a dependent system. That's the meaning of it. So I think it's pretty straightforward. Now, let's discuss some properties of determinants because it's going to help evaluate them if you're doing by hand. The value of a determinant changes sign if any two rows or any two columns are interchanged. So for example, we've done this before, but this is 3 times 2 times minus 1 times 4 or 2. Now let's change the first row and the second row. So 1 and 2 becomes the first row, 3, 4 becomes the second row. Now notice what happens. Now the determinant is 1 times 4, which is 4, minus 2 times 3, which is minus 6. The result is negative 2. Because we changed it, it's the same answer but negative. So it's the opposite of that answer. So if any two rows or columns are interchanged, that's what happens. Okay, the sign changes. If all the entries in any row or any column equals 0, the value of the determinant is 0. I mean, that's pretty straightforward. If any rows or columns, because 0 times 2 minus 0 times 1, the answer is 0. So that's why if any row or column is 0, or any row or column has more zeros than the other ones, that's the one that you want to use to expand it with respect to that. That makes it much easier. If any two rows or any two columns of a determinant have corresponding entries that are equal, the value of the determinant is 0. For example, notice these two are identical. Because the two are identical, if you work it out, it becomes 0. So you are going to expand it with respect to this one. You're going to cross. You're going to expand it with respect to this one. So if you cross this one, you get 1 times whatever is left. So just look at that one. The rest of them, you get this one. You get this one, right? And what I want you to notice, this is plus, minus, plus. I told you, you don't have to memorize that negative 1 to the power of 1 plus I plus j. Just remember they alternate. And so when you do the math, so this is 1. This 2 times 6 is 12. 3 times 5 is 15. So that gives you negative 3. So this is minus 2, minus 2. 1 times 6 is 6. 3 times 4 is 12. Their difference is minus 6. This is minus 3. 1 times 5, 5. Minus 8 is negative 3. And if you add them up, negative 3, positive 12, negative 9, they result in 0. So when two rows or columns are identical, the determinant becomes 0. So that's also nice to know. Again, speeding up the process. Speeding up the process. If any row or any column of a determinant is multiplied by a non-zero number k, the value of the determinant is also changed by a factor of k. So we said this was 2, as you recall, because 3 times 2 minus 1 times 4 is 2. Now let's multiply this one by some number, for example, k. So this is 3k times 2, 6k minus 4k times 1 minus 4k equals 2k. So 2, because this is multiplied by k, the result is multiplied by k. Again, to speed up the process, if we knew this, we could do this by just looking at this and multiply by k. If the entries of any row or any column of a determinant are multiplied by a non-zero number k, and the result is added to the corresponding entries of another row or column, the value of the determinant remains unchanged. So again, this one, we already know the answer is 2. Let's multiply row 2 by negative 2 and add it to row 1. So if we multiply this one by negative 2, let me just write it so you can see what we have. If I multiply this one by negative 2, 1 and 2 becomes negative 2 and negative 4. Now I'm going to add negative 2 to 3. I get 1. I get negative 4 to 4, and I get 0. Okay. And now 1 times 2 minus 1 times 0 is 2. We get the same result. So again, if the entries of any row or any column of a determinant are multiplied by a non-zero number k, and the result is added to the corresponding entries of another row or column, the value of the determinant remains unchanged.